Welcome back, everyone. We're going to take a look at using some really neat equipment made by the company Vernier. They're a really great company. They do lots of things that's useful for public schools and private and public colleges and universities. The software we're going to use and the hardware we're going to use, it can be used for graduate level research or something as simple as just basic temperature readings and stuff like that, which is something that we'll take a look at. We'll use that. Temperature changes in temperature are always very, very important. But I want to show you how to hook this stuff up. Okay, I want to show you how to get this going. So right here, this is your Lab Pro. All right, this is the Lab Pro. It kind of looks like a little bit like an old TI calculator. I'm not trying to compare products or whatever. I'm just saying it kind of looks that way. So here's an old Lab Pro, and you'll notice it has a little kickstand in the back, so you can easily set it up like this. And then you'll notice that there are some ports on one side here, and then there are some ports on the other side here. Inside this box will be a power adapter. All right, and so the kit you get may or may not have this white box, but you'll definitely have a power adapter. All right, so let's put that off to the side. Then you're going to have your interface cable, and if you look closely, you'll notice that one side looks like the typical USB, and then this is kind of like a Thunderbolt type one. This is just that or like a USB sort of interface cable as well, the other end to it. All right, so you're going to need both of these. Obviously, the USB part, this is what's going to go into your computer, and this is the part that's going to hook up to your Lab Pro. All right, and so where the Lab Pro is, you'll notice that on one side there'll be this little USB marking here, and on this part of the connector, the same mark is there, and it's keyed. There is no way you can not get that correct. All right, on the same side here, you will see it says Digital Sonic 1 and 2. You won't need these except for special equipment that we're going to hook up. Typically, the ones that we're going to use, you'll need this side where you see that there are 4 ports, and they're called channels. So you got channel 1, channel 2, channel 3, channel 4. Okay, and you've probably already realized you can actually hook up 4 different pieces of test equipment, some probeware, some sensor to this, and take 4 different types of data measurements simultaneously. It's a beautiful thing. All right, and so then obviously you've got your power adapter, and then the universal symbol for the power adapter is that little, that's one of those right there. So either you have a little circle with a line in it that says on or off, but this right here is a universal symbol that says, hey, hook this up. So I'm going to hook it up. So that's hooked up. We just have to plug this into some power. And you hear what we call the happy noise. I'm very sure that's literally what they called it when I went to this training like years ago. They call that the happy noise. If you don't hear the happy noise, it's not hooked up correctly. Take the USB portion of the interface cable, find a USB port, it doesn't matter which one, just find a USB port, and plug it into your computer. Now at this point, what you want to do is find the Logger Pro software on the computer that you're given. You can bring in your own personal computer if you want. I have a license that says you can have a copy of this software. I recommend you do that. All right, and then when you do, all you do is open up the Logger Pro software. You see it loading, and if you look very, very carefully, that doesn't help. Let's take a look at how to use the software. So we're going to find an icon that looks something like this. It says Logger Pro. Now I'm using my MacBook Pro, so the interface is going to look a little bit different than it will on a Windows computer, but the commands are the same thing. So on a Mac, you have things up here that basically let you know where all of your or the command prompts are. In Windows, it's built into the window itself. But once this particular piece of software is up and running, notice up here it says Logger Pro. So when you open up Logger Pro on a Windows computer, you'll also see File, Edit, Experiment, Data, Analyze. You'll see all of this stuff right here. Okay, so it's still going to work. It's still going to, for training purposes, this is going to be just fine. So of course you've got your Lab Pro, and then you have to plug it in, which I'm getting ready to do. And we get our happy noise, just like we are supposed to. So this is a good thing. And now I'm going to plug in into the USB port. Now I have interfaced between the Lab Pro and my computer, as I showed you in the first part of the video. So now I'm going to take a temperature sensor and I'm going to plug it into channel 1. And what I want you to do is when I plug it into channel 1, then you're going to see something happen up here on the screen. Pay attention to that. And you see immediately that the software recognizes that I've put a temperature probe into the Lab Pro, and right here we see what the temperature reading is. So you can see 24.9 degrees Celsius, notice here and here it keeps toggling back and forth. So that is the temperature here in my lab at the moment. So no matter what you put in, if we were to put in a conductivity probe, then it automatically recognizes that you have a conductivity probe, and it would say conductivity, and the unit of measurement would be there. No matter what you put in, a pH sensor, a motion sensor, it doesn't matter what you hook up, it automatically recognizes it. It's the beauty of the hardware and software. Vernier has done a wonderful job with the interface here. So notice the temperature has gone up a little bit. I actually placed this temperature down on the table, right where a sunbeam is hitting the table, and so it's increasing a little bit. So right here it just says untitled because it's an untitled file. So when you're done, you would have your usual commands where you would click and you go File, Save As. So like anything, whether it's Word, PowerPoint, Excel, Logger Pro, in any program, it's all these commands up here. They're File and Edit, Options, things of that nature. Help. All of those are standard. So new. If you want to start something new, if you want to start a new one, you obviously would click that. And it would ask you, it would go through some prompts. Do you want to keep the current data you have? What do you want to do with it? But I always recommend you always save your data that you have before you would open a new file. And of course, there's ways to set the page, which we can take a look at. Printing options. You're not going to print what you need, although from printing options or from print, just like with Word or any other program like that, from there you will usually have an option to save things like as a PDF or something. You could import from another device, so you could import data from the Lab Pro. So there are different mods that you can hook up, or different types of Lab Pros, like called a Lab Quest, where it actually will pull in data. So say you want to go out to a river, or you want to go outside and collect data, or you want to move around, and you don't want to be tethered to a table and the computer. You can actually, it's very transportable, and so that's when you would do something like this. Text files, those are a general file that are used for just general information that can be opened by pretty much any computer. CSV files, so that means you're using Excel, and so Excel is used a lot. Oops, I hit that by accident. Excel is used a lot for spreadsheet calculations. It's an incredibly powerful program. In Edit, you can see right now it's grayed out because there's nothing to choose from, but there's your basic commands, etc. So Experiment, anything related to the experiment that is going to be there. Start data collection, which also is the same as this button right here. This is also start data collection. There's a little like a play icon in there, and it's green, which means go. So it's fairly intuitive. And like with anything, you just have to get familiar with the software, which is the whole purpose of this video here. Once you have data you have options that you can do as far as manipulating your data, and I'll do some stuff here on this video for you to kind of help with that. And then what's really powerful about this software and about this technology is that you can do so much data analysis. There is a wonderful, wonderful range of data analyses that can be done here. So, and I recommend that you get familiar with this. There's things on here that I've never used because I've never had to, but this software is powerful enough to actually use for some graduate level research. And then of course you can insert a variety of things. You can actually import movies, and we could actually visualize things in movies, and we may actually do that. Or I might actually bring something in where we do some stuff like that. It actually is quite interesting. Video capture, yes, we can capture some video. Gel analysis, so in biology, with genetics, there's this thing called gel electrophoresis. So we can actually hook up some equipment that runs those DNA gels, and we could actually get that data here and analyze all of that using this software. I mean, this stuff is just wonderful. And then of course options. It's going to be particular, but you'll see options that are very familiar to what you're used to. Okay. All right. So while I've been talking, the temperature's been going up. Let's do something here. I'm going to go. I don't know. I'll be right back. I'm going to go get some water. Let's go ahead and get some data on this graph. So I'm going to click Data Collection, and you can see that as I start once I've done that, you'll notice that right here on this point of the graph matches this, and you can see your t-chart, and it's literally collecting data every 0.5 seconds. It is pulling in data, so you could see that in a very short period of time we can get a huge data set to give us lots of data points to help us really have better precision and accuracy in measurements that we have. It's just up to us to put together an experiment or an investigation in a way that helps eliminate any sort of error. And so right now it's pretty much staying steady because the temperature, it's not changing much. It defaults down here to 180 seconds, but we could always go in and actually change how long it runs. And so I've had labs before with biology students years ago where we actually let it run overnight, and I just set it for an indefinite amount of time, and we just let something happen overnight, and we had a huge data set that we were able to analyze. It was wonderful. So right now I'm going to take the temperature probe, and you'll notice that it starts to heat up. What I've done is I have put it inside my hand, and I've gripped the temperature probe very tightly, and obviously the heat from my body is being measured and being absorbed by the tool. Sort of breathe a little bit of warm air into that, and you see that it's sort of spiked up just a little bit more. And so I'm just making this up. I just need some data on the screen so you can look at it and see how responsive it is. Now I'm going to take this. This is just a beaker with some tap water, and you can see how that temperature immediately drops, right? And now you can see it's starting to stabilize. So we got that immediate very sharp slope, so obviously that'd be a huge rate of change, and now we have a smaller slope, so we have less of a rate of change. And so now I'm going to add in one. I'm just adding in ice cubes. I'm just going to pour in some ice cubes. Why not? Now I'm going to take the probe, stir it, and you can see very quickly we're getting closer and closer to the 0 temperature mark. We're going to run out of time soon, but you can imagine that if I let the time go long enough, and all the ice is almost melted, which makes sense. Notice this slope is starting to sort of taper off, right? So if I had have kept adding ice and kept stirring, I eventually could have got this thing down to 0 degrees Celsius, the freezing point. So right now it's nice and cold. So I just had the default 3 minutes is what I used. Okay, so it stopped. So now the excuse me, the question is, let me get a sip of coffee. Okay, I'm ready. So the question is what in the world do we do with all this stuff now? Well, up here, you can see that you've got a button, and the buttons look like this. I mean, Mac software has, the images look a little bit different, but this exact same shape is, all of these things are in this order on the Windows software as well. Okay, so you can see positive, negative. Obviously, we could zoom in, we could zoom out. So I'm going to zoom in. Now I'm going to go, and just zoom out. All right, I just zoomed out twice. So the first time I just did Command Z, or on a Windows computer you'd go Control Z, which is undo, right? So zoom in or out, and I'm back to where I was. You could do this button right here. It says Auto Scale the Graph, and so if I click that, what it does is, with whatever is there in the time span based on whatever your independent variable is, what it does is sort of auto scale it in a way that gives it a best fit on the X and the Y variable based on the highest data point on the Y variable, okay, and the X, to kind of, and that's what the auto scale is, So undo auto scale, put it right back to where it was. So you can see, edit, undo, redo auto scale. So it's just like using a Word program, the Word program. It's very, very intuitive. All right. Now right here, this examine button, this is going to be your friend. If I click on this little box pops up, and you can see the unit of measurement, time S, and notice down on the X-axis, you've got time with the S, with the seconds unit, temperature, your y-axis, degrees Celsius in parentheses. So it immediately shows your X and Y variables. The wonderful thing about this is, as soon as your cursor makes its way onto the screen, and all I'm doing is just moving my mouse along the curve, and you can see to the left as well. Look, see on the left how as I move this to the right or I move it to the left, that it's basically moving along each data point that was collected in this data set. And so let's just say that I really want to know what this point right here is. And it's pretty, all I got to do is go and hover over that point right there on the left on my T-chart. My exact numbers are there. If you look up at the box at the top left where the graph is, notice the numbers in that box match what we have here on the T-chart at point 154 that was determined. So now the great part of this is, as you move, it's going along that curve. There's a whole lot that can be done here. We can look at a whole lot of data here. We can figure out what's happening at all of our points along our curves as our slope increases and decreases, as it becomes more and more intense. All right. If you want to, you can always, as well, on a Windows computer, you may not get a hand that looks like this, but you can grab this box and you can put it wherever you want. Let's just say you don't like it over there, put it over here so you can look at it. Whatever makes you most comfortable. It's pretty versatile. All right. So close this. Let's take a look at this. Hover over it and you see it says tangent. And so those of you who are familiar with your tangent, notice you've got time, your X, and then for X, or for the Y, I'm sorry, it's giving you the temperature slope, and it literally is, notice it says degrees Celsius per time. And so if you're familiar with a tangent line, you can see that dark line. You can see this right here. If I were to click right here, anywhere that I go along this, you remember that a tangent is at that one point. Where does where at that point, where is there an intercept along the curve where there is that straight line? And so right here at this point, the slope of that line right there at that data point is a negative 0.505 degrees Celsius per second. So that's the rate of change. That tangent point gives you an instantaneous piece of information. So if we were talking about, say, something with velocity, it would give you, say, like your instantaneous velocity. At that point, what's your rate of change? Very powerful tool. Anywhere you go, tangent is just always letting you know at one point what your rate of change is. Okay, close that box. So right here, the statistics button, you'll see that it put a bracket at the initial data point and the final data point that was collected. And what it's doing is giving you all this wonderful data that's within the range of what's being chosen. So your mean, median, and mode, and of course those numbers are reflective of this constant here, this rate of change, and everything. So so if you want something that's a little more precise, then you choose a different data set. So it could be that you want to know what's happening with the slope right there. Well, what would you do? You would change your range, and now you get something that's more reflective of that exact curve right there. You could be that you really wanted to know what was going on right there. Right there is when I first put that sensor into the water, and you could see that there was that drastic temperature change. And so it gives you your minimum, maximum values, your mean, median, mode. It gives you your standard deviation, how many samples that you had within that. It's again, more powerful tools. These are wonderful. So let's close that out. Let's take a look. Integral. We'll use this from time to time, maybe, but of course, click on integral. You're going to be looking at the area under the curve, and there's a lot of important data that we can use from integrals. Depending on what type of lab we're doing, we may incorporate this into what we're doing for some data analyses. But the area under the curve it can give us some good data, and when we need that, we'll talk about that more. Right here, linear fit. This is a wonderful tool. Click on linear fit. Notice that it gives the brackets again from the first to the next data point, and a little bit different information is given. And you'll see it says temperature equals mt plus b, so you should immediately recognize this is y equals mx plus b. This is our slope form right here, so we can get our y-intercept, we get our slope, we can get our rate of change. And this is absolutely great, a great tool. You will be using this tool a lot. All right, you typically use this a lot in algebra, and the focus of a lot of the class that we work on has to do with algebra, and we integrate some trig and other functions, math functions into that as well. You're going to be using this quite a bit. And again, as usual, if you say, oh, I don't like it there, I want the box here, by all means, do that. Okay. All right, and then you've got right here where you've got a curve fit, and so let's just say we're working on a particular data set where we're not quite sure what we have. It may not necessarily be a straightforward linear model. All right, we can click on this, and we can actually choose from various relationships that we think may fit. We can actually manipulate the data to take a look at what is there to see if there is a better function that describes the data that we are observing. This is such a powerful tool, and this is why it's very useful for graduate research. Okay. And then you can try it out. You could click on any of these relationships, you can try the fit, and you can actually see what happens. Okay? And then right here, data collection. So if I click on this, you see where there's that standard 180. So I could go in here and change it from seconds to minutes to hours. I can have it. I can set the time. I can tell it to repeat that cycle over and over again. You can see the data samples every zero point 0.5 seconds. But if you want to change that, here's where you have the power to do so. Right here, it's taken 2 samples during that amount of time. You could change that to whatever you want. If you realize that the type of data you're collecting moves at a slower rate and you don't want that many data points in a short amount of time, you would rather your data points be stretched out over a longer period of time, you have the power to change that. Okay? You have the power to change that. Don't worry about the triggering part. Cancel. Then, of course, here's where you start and stop your data collection. And then, you'll notice that if I come over here, click on the graph again, notice how these little squares show up, right? Well, that looks just like a picture. And notice now when I hover over the y-axis, it says I could click and drag it. So let's just say you don't want to auto scale. I recommend avoiding auto scale if you can. And I'm just clicking and holding and I'm dragging this. I recommend that you actually control your data. You actually control your graph. You have so much power here. All right. You can click on the y-axis and it tells you the unit that's there. If I go to more, then it gives me options where I can change the label of it. I could actually turn that off. So there's times where you may have multiple y-axes that you want to look at, and we will actually have some labs where you have multiple things you're looking at simultaneously, and you'll see 2 graphs on the screen. Okay, but here's where you have control over that, and the same with your independent variable. You're on your x-axis right here. Let's just say for some reason you wanted to reverse the variables. Then you could just come here and you could tell it to choose that column of data, and it would switch it for you. Okay, or let's just say, you could go in again to more, and you could actually you could define that. You can change it there if you want. You can auto scale it large or different. I recommend avoiding auto scale. I really, really do. All right. And then again, you can manually change your axis. Okay. So what I just did was double click on the graph. If I double click, then it brings up graph options, which if you go to options, graph options. So just, in any sort of software, there's usually multiple ways to get to something and to do something. You could put a title of the graph. I've got a title of the graph. Boom, there's the title of the graph. All right. Come back here if you decide you want to change the color. I like plum. We're going to go with plum. Now I have a plum colored title. All right. Don't get psychedelic. Just leave it black or something like that. All right. From the graph options, you could choose where you interpolate. You could add in error. It's automatically going to be able to add in error bars for you. And of course, it gives you little notes about your error bars. And there'll be times where we may need to do some stuff with error bars. Those are very, very important. They can be very, very useful depending on what type of analysis you're looking at. And then, of course, you can change the way the grid looks. Right now it says solid with no lines. If I want to go dotted and I click OK, then all of a sudden I've got dotted lines here. You can dress this up in so many ways. It's just wonderful. Your axes options, here's where you can actually define and set multiple axes options where you can switch back and forth between what your variables are. And again, the commands are pretty much the same in a Windows software. Okay, so this should help. Page, you can go. You can have multiple pages on this. What's really useful is you see how here where you have copy, cut, copy, delete. Be careful what you do here, but this is basically an image. So you could click on this, or you could click on the graph, or you could click right here on the data table, and you can go edit, copy, and then you could go into a Word document and paste the data table, and it'll just paste what's visually in that square. And or if you have the graph and you go edit copy, or you go Command C, which is copy, then or Control C on a Windows computer, then it'll copy it. You go into your word processing software, you put it in there, and you can embed your data. And you will be doing that. There'll be reports that you will have to give me where that happens. And then at that point, it's just an image, and you manipulate it like you would any image in the software, in the in your processing software. And that is pretty much it. That should be able to get you started up and running. And of course, here's where you can open a folder, do stuff. If you go File, Open, it's going to open up some preset data pages that are already made for certain labs that we're going to be doing. And that's where that would be. And then other than that, it's just particular to whichever probeware you have attached. That's what's going to affect what happens, what shows up on the screen, and then of course your data is going to be reflective of the probeware or the sensorware that you have. All right, I hope you enjoyed this. I hope this was helpful. Please watch this as often as you need to. Use it as a reference guide. And then, of course, there's no substitute for experience. So as you use this more and more in class, you get more and more experiences, and you're going to get much more adept at using it. So, and then of course, if once you go File, Save As, then of course you would have the title that would appear right there. Okay. All right, I'll see you in lab. Good luck. And that's it. It's fairly easy to use. Your job, the hardest part is, well, what you saw was just basically unpacking it, putting the stuff back up. Of course, you're going to have to wipe it, keep it clean, and stuff like that. We just always do that with anytime we're in lab. You're always going to clean anything that you use. It's just standard lab procedure. And then I recommend that you get a copy of the software so you can manipulate all the data that is in here. This is a very powerful piece of software. We're going to be using this quite a few times. We use this a lot in physics and chemistry, and I've used it in biology classes that I've taught as well. There's actually multiple things. We can do pH, we can do dissolved oxygen, there's respiratory things. I've done EKGs using this. There's EKG sensors you can get. It's really cool. You hook all these EKG probes up. There's just a ton of things that you can do with this. It's wonderful. Conductivity probes, we're going to be doing a lot. It's going to be a lot of fun. Your job is just to read the instructions and know when you come into class what you're going to be doing, so that you can have it in your mind that this is the type of data I'm going to be collecting. So when I look at this graph, it makes some sense. It kind of, I don't know, it's understandable to you. That's going to be the biggest challenge. It's just coming prepared, which I know you'll do. Hope this helped, and I'll see you in class.